Alright, in this video we're going to work on solving quadratics by taking the square root. Remember, whenever we can see a quadratic and we're asked to solve it and we're missing the middle term, we're missing just the plain x, or in this case the plain n term, is when we can solve by the square root. So that's when we're missing the b term. Remember, when I talk about the b term, your standard form of your quadratic is this form. So when I'm missing the middle term, the b term, the one with the plain x, the linear x, is when you would solve by square roots. So in this case, example 1, I'm going to add 2 to both sides. I wind up with 7n squared is equal to 175. My next step is to divide by 7. We're trying to get the variable by itself. So then I'm left with n squared is equal to 25. I'm going to take the square root of both sides. Okay. Square root of n squared is n. It's going to be plus or minus the square root of 25 is 5. So my n here is equal to positive 5, and it's equal to negative 5. Okay, second example, again, I notice I'm missing my b term. So I'm going to subtract 9 from both sides. So 393 minus 9 gives me 384. So I'm left with 8v squared is equal to 384. Divide that by 8. And I get that v squared is equal to 48. Okay, so now we're going to take the square root of both sides. Alright, square root of v squared is v is equal to plus or minus the square root of 48. Okay, so that's when I start dividing it out. Is there a perfect square? So 48, perfect square is less than 48 is 36. 48 does not divide evenly by 36. 48 divided by 25 doesn't work. 48 divided by 16 does. So if I divide that out, I wind up that I have square root of 16 times 3. Okay, and then v equals that. Square root of 16 is 4, so v is going to equal plus or minus 4 times radical 3, and that would be my answer. So you could write it like that, or you could write v equals 4 radical 3 and negative 4 radical 3. Either one is acceptable. You might see it written either way on the exam. You might see the plus or minus notation, or written out 4 radical 3 plus negative n. Negative 4 radical 3. So be prepared for both. Okay, my last example here, I'm going to add 8. Add 8. So I have 4n squared is equal to negative 58. And then we're going to divide by 4. Divide by 4. So I have n squared is equal to negative 58 divided by 4. Okay. It gives me a negative 14.5, which, number one, it's hard to take a square root of with the decimal. But the big thing is here is that when we go ahead and keep going with this, if I wanted to do this, when we get a negative like that, I would revert to, instead of dividing it out, I would revert back down to the fraction and take the square root this way. Okay, and then we would have n squared is equal to the square root of negative 58 over the square root of 4. Okay, and then we keep going here, but we know, hold on, this would be just n because I took the square root of it. So I would have n equals plus or minus the square root of negative 58 all over 2. But remember, when we have a negative in here, we know that that's going to become plus or minus I radical 58 all over 2. We already know that 4 doesn't divide evenly in this, and there's no other perfect squares that go into 58, so we would leave it like this. Also remember, when you have the negative in the radical, that this becomes an imaginary solution also. Alright? So if you have any more questions on solving by square roots, please see me in class.